Hello dear friends, welcome to Unacademy GATE ESE. This is your educator Apuroop and this is Concept in Minutes, and in this video we are going to talk about the concept of thermal stress. How exactly thermal stresses are developed, what is the condition in which we are going to get thermal stress, what exactly is thermal stress, that we are going to understand in this video. So this is a new video series that I have started, Concepts in Minutes, in which in every video we talk about one particular concepts within a few minutes. इन लेक्चर्स में मैं कोशिश करता हूं कि कम से कम समय में किसी एक कॉन्सेप्ट को बहुत अच्छी तरीके से आपको डिलीवर कर सकूं, so that that concept will be crystal clear to you. You can answer all questions related to that concept in your exams as well as in your interviews. तो ये लेक्चर वीडियोस जो हैं एग्जाम्स, रिटन एग्जाम्स के लिए भी बेनिफिशियल हैं और इंटरव्यूज के लिए भी बेनिफिशियल है. ओके, तो बेटा अगर आपके पास भी कोई सजेशन है किसी पर्टिकुलर कॉन्सेप्ट को लेके, अगर आप चाहते हो मैं वीडियो बनाऊं, देन राइट इन द कमेंट्स. ओके, नाउ बेटा लेट्स फर्स्ट इंट्रोड्यूस माय सेल्फ. माय नेम इज अप्रूप राव, ऑल इंडिया रैंक 320 इन गेट मैकेनिकल, एमटेक फ्रॉम IIT खड़गपुर. माय स्पेशलाइजेशन वाज डिजाइन. I have 2+ years of experience working in the field of design of cars at Mahindra and Mahindra, and 6+ years of teaching experience for GATE and ESE, and I teach subjects basically related to design, strength of materials, machine design, engineering mechanics and theory of machines. Now let's get into the concept of thermal stress. So beta, what exactly is thermal stress? So if you ask me, there is no technical term such as thermal stress. Thermal stress नाम का कोई technical term नहीं है. Basically thermal stresses are stresses developed due to change in temperature. तो thermal stress जैसा कोई एक technical term नहीं है, हमने ये term बना दिया है. We have made this term because these stresses are developed due to change in temperature. Okay, now let's understand the situation when we will get thermal stress. Okay, so let's say we have a cube or a cuboid. Let's say we have a cuboid which is free from all sides. It is free from all sides. Let's say this is the length, this is the width and this is the height. Okay, it is completely free from all sides. ये किसी भी साइड में कंस्ट्रेंट नहीं है, हर साइड से ये फ्री है. ओके, नाउ लेट्स से वी आर increasing the temperature by delta T degree centigrade. Okay, we are increasing the temperature by delta T degree centigrade. Okay, so if I increase the temperature of this block by delta T degree centigrade, what is going to happen? It's a solid material, so obviously with increase in temperature the material is going to expand. अगर टेम्परेचर बढ़ेगा तो मटेरियल एक्सपांड होगा. इफ आई डिक्रीज द टेम्परेचर द मटेरियल इज गोइंग टू कंप्रेस. नाउ दिस एक्सपांशन इज गोइंग टू टेक प्लेस इन एवरी डायरेक्शन. ये एक्सपांशन हर डायरेक्शन में होगा. मींस द लेंथ इज गोइंग टू इंक्रीज, द हाइट इज गोइंग टू इंक्रीज, द विड्थ इज आल्सो गोइंग टू इंक्रीज. राइट, नाउ द क्वेश्चन इज what will be the magnitude of that change? So understand beta, the change in length is given by this simple relation, this simple equation, which is L alpha delta T. Similarly, change in width is W alpha delta T and change in height is H alpha delta T. Now L alpha delta T, in this equation L is the initial length and delta T is the increase in temperature. But what is alpha? So alpha is basically a material property which is known as coefficient of linear expansion. Coefficient of linear expansion, and it is a material property, means its value depends upon the material, alpha of steel is around 12 into 10 to the power minus 6 per degree centigrade. ठीक है, यानी ये वो वैल्यू है जो मटेरियल पे डिपेंड करती है और स्टील के लिए इसकी वैल्यू इतनी होती है. ओके, नाउ अंडरस्टैंड बेटा, these are the change in dimensions due to change in temperature. The dimensions also change due to forces, right? Force की वजह से, due to axial forces also the dimension change. If I apply an axial force, then also the length will increase. So beta, how we are going to differentiate whether the length is increasing due to force or due to temperature? So now we are going to introduce a term which is known as delta L thermal. Okay, I am going to write it delta W thermal or delta H thermal. So understand beta, if I ever write this delta L thermal, then this is change in length due to temperature, and if I ever write delta L mechanical, then this is change in length due to force. Okay, and the total change in length in any situation is delta L thermal plus delta L mechanical. If there is only temperature change, then beta del L mechanical will be 0, and if there is only force, no change in temperature, then del L thermal will be 0. If there are both, अगर दोनों हैं, increase in length due to temperature plus due to force, then both will be there. So del L total is del L thermal plus del L mechanical. Okay, this is a new term which we have introduced. Okay, now this is the situation where the body is free in all direction. So if the body is free, then beta what will be the stress in the body? Stress क्या आएगा body में? So beta in this case sigma x will be 0, sigma y will be 0 and sigma z will be 0. Because beta there is no force developed in the body. यहाँ कहीं पे भी force develop हो ही नहीं रहा है. Is there any force in x direction? No. Is there any force in y direction? No. Is there any force in z direction? No. So beta there will be no stress. Stress will only be developed if there is a force or a moment. Right now there is no force, there is no moment, so no stress. But there will be strain. यहाँ strain रहेगा बेटा. What is epsilon x? Epsilon x will be delta L by L. And what is delta L? Del L mechanical is 0, but del L thermal is not 0, right? It will be L alpha delta T divided by L. So this will be alpha delta T. What will be epsilon y? Delta y में कौन सा dimension है? H. So delta H by H, which will be H alpha del T divided by H. So alpha delta T. And what will be epsilon Z? Delta W by W. W alpha delta T by W. So it will also be alpha delta T. So sigma xyz 0 है, but epsilon xyz are not 0. They are equal to alpha delta T. So do you understand this concept? But beta there is a very controversial statement here. The stress is 0 but the strain is not 0. How come it is possible? In any direction the stress must be proportional to strain, right? If there is stress there should be strain, if there is strain there should be stress. So how it is happening? Understand beta, that Hooke's law which states that stress should be proportional to strain is also valid here. But beta that law is only applicable to mechanical strain. This is total strain. ये जो strain है ये total strain है. Mechanical strain plus thermal strain is alpha delta T, but mechanical strain is 0. Thermal strain is alpha delta T. So mechanical strain is 0, stress is 0. So stress is not proportional to total strain. Stress is proportional to मैकेनिकल स्ट्रेन, मैकेनिकल स्ट्रेन 0 है, स्ट्रेस भी 0 है. So Hooke's law is valid, but beta this strain is not mechanical strain, it is total strain. So this stress is not proportional to this strain, the stress is proportional to mechanical strain. Okay, now understand, this is the situation where the body is free in all direction, right? Now let's constrain the body in any one direction. अब किसी भी एक डायरेक्शन में बॉडी को कंस्ट्रेन कर देते हैं. लेट्स कंस्ट्रेन द बॉडी इन एक्स डायरेक्शन. अब बॉडी को एक्स डायरेक्शन में कंस्ट्रेन कर देते हैं. लेट्स से दिस इज द लेंथ ऑफ द बॉडी एंड नाउ वी आर इंक्रीजिंग द टेम्परेचर. Now we are increasing the temperature by delta T degree centigrade. So now what is going to happen? Understand clearly. First of all, if I increase the temperature, all the dimensions should change. Length should change, width should change, height should change. Okay. Now understand beta, the width and height can freely change because there is no constraint in Y. There is no constraint in Z, so width will freely increase, height will freely increase. But when you will increase the temperature, the length cannot increase. Why the length cannot increase? Because I have fixed the body in X direction. So what is going to happen? Understand clearly. This right face is trying to move towards right side. Because of the expansion, the right face is trying to move towards the right side, but it is not happening. Why? Because there is a support. So the right face is going to apply a force on the support towards the right side. ये right वाला face जो है support के ऊपर इस direction में force लगाएगा, ऐसा force. तो बेटा support will apply an equal and opposite force towards the left side, means on this side. Right? Now, this left face will try to apply a force on this side because it is going to expand. So, left face is trying to apply force on this side. So, beta the support will apply a force on this side. So, beta there will be another reaction from this side. हाँ कि ना? Now, understand beta. The body should be static, it should not move, means summation of fx must be 0. Summation of fx must be 0. So if summation of fx must be 0, means if this is p, this must be p, right? There is no other force in the middle. अगर बीच में कोई फोर्स लग रहा होता, अगर बीच में मान लो 100 न्यूटन का फोर्स लग रहा होता, तो बेटा दिस में भी P1, दिस में भी P2 ऐसा होता. बट बेटा अभी कोई फोर्स नहीं लग रहा बीच में, देयर इज नो फोर्स इन बिटवीन. तो बेटा इफ दिस इज P, then this is also P, right? Now what is this diagram? This diagram is the free body diagram. How many unknowns do you see here? Earlier there were 2 unknowns. पहले 2 unknown थे, this one. But after applying the equilibrium equation, there is only one unknown, P. Now the question is, how you are going to find the value of P? Understand beta, the problems of thermal stress are statically indeterminate. Problems of thermal stress statically indeterminate होते हैं. क्यों होते हैं? बेटा statically indeterminate problems are the problems where number of unknowns are greater than number of equilibrium equations. Now when do we get statically indeterminate problem? When the body is not free to deform. When the deformation is constrained, then we get statically indeterminate problem. Okay, statically indeterminate problems के ऊपर I will make another video. तो statically indeterminate problem का मतलब है कि body जो है वो कंस्ट्रेन है, फ्री नहीं है एक्सपांड या कंस्ट्रेन कॉम्पैक्ट होने के लिए. तो मेरे भाई हियर आई हैव constrained the expansion in x, that's why it has become statically indeterminate. And for every statically indeterminate problem, we need to apply compatibility equation. तो यहां compatibility equation क्या बनती है? What is compatibility equation? Compatibility equation means the equation of constraint of deformation. आपने deformation constraint किया है, कैसे किया है, उसकी equation is known as compatibility equation. तो यहां कैसे constraint किया है? बेटा length को fix कर दिया है. So change in length must be 0. Which change in length? Total change in length. Now what is total change in length? Delta L thermal plus delta L mechanical. This is the delta L total, right? Now in this equation, delta L thermal will be equal to what? I have increased the temperature. So delta T is positive. So del L thermal will be positive. L alpha delta T. This is positive. Now what will be delta L mechanical? Change in length due to force. Now the force is compressive. So del L mechanical will be negative. PL by AE equals to 0. Now beta, can I write it like this? L alpha delta T equals to PL by AE. Now L and L will be cancelled. So beta, this will become alpha delta T equals to P by A into E, right? Now in this equation, this P by A is what? Sigma X. So can I write sigma X equals to E alpha delta T? Are you getting this? Yes. So this is the equation of stress in X direction. Ha ki na? This is the equation of stress in X direction. So this is how thermal stresses are developed. When you constrain the deformation and then you change the temperature, then only thermal stresses are developed. Okay. Now beta, there are a lot of problems of thermal stress. I can fix this body in X as well as in Y direction. So beta, in that case also you will have to use the same concept. You will draw the free body diagram and then you will apply compatibility equation. Compatibility equation is the key of solving problems of thermal stress. If you know how to write the compatibility equation, you can solve any problem of thermal stress. If you want to see what are the different types of problems of thermal stress and how to solve them, then watch my lectures of strength of materials by opening this one link. You will get the entire playlist of SOM well organized and you will also get the PDF notes of those lectures. आपको पूरे strength of material के lectures मिल जाएंगे और उनकी PDF की link भी मिल जाएगी. बस इस एक link को खोल लीजिए. Just go to any web browser and in the address bar write this down, just like facebook.com, youtube.com, write down tinyurl.com/Apuroop10, open this page and you will find all my video lectures completely free and also the notes of those lectures. And if you don't want to miss my classes, then just go to this Telegram channel. Just open your Telegram app and search Apuroop10, join this Telegram channel and you will get the link and notifications of all my classes. Okay. And beta, if you want to get into proper batch course, take Unacademy Plus subscription. Okay. Beta, you will get everything completely free on YouTube lectures. आपको कभी भी recorded videos खरीदने की जरूरत नहीं है. आपको सब कुछ यहाँ YouTube में मिल जाएगा completely free. हमारी batch है K2K batch, कलम टू कलाम batch, उसमें सारे subjects cover होंगे. But there are some things which are not possible on YouTube. Lot of things are not possible on YouTube. For example, daily assignment, weekly quizzes, online test series, question bank, classroom-like environment, doubt clearing sessions, guidance, then beta notes after every class. All these things are not possible on YouTube. They are possible on Unacademy Plus. So take the Unacademy Plus using this code Apuroop10. You can use this code in order to get 10% off. And if you use this code beta, you will be under my personal guidance. I will guide you throughout your preparation. तो मेरी guidance में अगर आपको prepare करना है GATE या ESE या किसी भी PSU के लिए, तो बेटा बस ये code लगा लो, Unacademy Plus का subscription ले लो and let me know. I will guide you throughout your preparation. Okay, message me on Unacademy app. अगर Unacademy app पे आप मुझे message भी कर सकते हो अगर आपको कोई भी doubt है. Okay. Now beta, before leaving, don't forget to hit the like button, share the session and subscribe to this channel. Okay. I will see you guys with more videos. If you want me to make videos on a particular concept, let me know in the comments. Okay. Thank you so much. Bye bye. Take care.